Yeah, thank you for coming to our talk on polymorphic interfaces in KCP, the three vendor problem. My name is Nelo-T. Wallus. I work for SAP, and I will present this today with Robert Vasek from Cluso. First things first, our work is of course funded by various people, and all of this happens as part of the Neo-Nephos Foundation, and we contribute to various projects within the CNCF and Kubernetes ecosystem. So KCP and its components are a CNCF project. KubeBind just got approved as a CNCF sandbox project. Multicluster Runtime is a Kubernetes 6 project, and Platform Mesh is a Neo-Nephos project. So lots of different things, but we all want to do the same thing. This is cross-cluster communication. But the Neo-Nephos Platform Mesh, what is Platform Mesh actually? It defines an environment that allows service providers to offer services of any kind to consumers and allow these consumers to discover these services and their capabilities, order services and control their lifecycle. Sounds like a lot, but in the end, all we want is that the same way we create a pod by creating a deployment, we want to order a service by creating a Kubernetes resource. And the Neo-Nephos Foundation has a load of cool projects, of which Platform Mesh is one. There's many other cool projects that do very cool things, and we are largely funded by the Bundesministerium für Wirtschaft und Energie. So, what is our agenda today? First, we want to talk a bit about the problem description. So what is the specific problem we are trying to solve under this umbrella of polymorphic APIs? Because just saying polymorphic APIs, it sounds cool, but what is the discrete problem? They have very different viewpoints depending on from where you are coming from. Then we want to give a bit of an introduction into KCP, because to understand what we are trying to do, you need to kind of know what KCP does and how it does this. So we will talk about a single provider, then a service with a single provider and multiple implementations, and then service with multiple providers. And we have a small demo where we show that this is already possible today. And then we'll just sum it up. So the problem description. If you remember, no problem. If you remember back in university when you learned about polymorphism, what actually does that mean? You have an interface, a contract that just says you get a request with specific parameters, then you give that to someone, to an implementation, and you get a specific response out of it. And that's all the grand idea. So that's what we already have with interfaces and programming languages. The easiest example of this is a certificate request. You just want a certificate. You make your secret, you create your certificate request, you want this to get signed by an authority, and then you want to use this. So basically, all we want is at the end that we have a secret with all of the signed data that we can then use to authenticate ourselves. And there are many good implementations for this. Of course, we all use and love Cert Manager, but there can also be corporate versions of this, or board versions, or that we have some specific requirements to use some kind of appliance to sign our certificates. But at the end of the day, we just want a certificate, and we don't care how we get the certificate. So, what are some other use cases for polymorphic APIs? Organizational limitations. You have a resource of virtual machines and you have two different teams, and you want to route the resource requests from these teams depending on what the team is and what this team is allowed to do. Another thing is execution environments. You want to order VMs and you have x86 and ARM64 hypervisors, and you want to route the request depending on where you have availability if the user does not care which version of CPU you get. Another one is load balancing, that if you just have multiple data centers and availability zones, you just want to route the requests to where you have availability again. legislative requirements is also a good example of this, where you just have your abstract service interface, and depending on the legislature, you need to store your data differently or handle it differently. So you need to route it to different DCs, and the specific implementation maybe has to differ slightly, but you don't want to handle these differences in the definition of your customer resources. You just want to have this handled automatically in the backend. Then the API marketplace, this is our most prominent idea, I would say, where you just have a platform and you have a set of standard APIs for relational databases or Kubernetes clusters or object storage and you then get a number of providers that can satisfy these interfaces, that can service these services. And then you have consumers. These can be external or internal. Doesn't really matter, but when they post a request, these requests are then served by any of the providers that can service this request. And the consumer doesn't care. They just want to have this service fulfilled. And you're just routing the request to a provider that has availability. And lastly, CI/CD, where we are going back to this. So a certificate request, you will see the certificate example a couple of times. But if you're deploying an application, you want to model your execution environment, but you sometimes can't model your execution environment. And if you have an abstraction in between with a API that just abstracts this away, you can just have your certificate request as your own API. And in local development, you're just using Cert Manager for self-signed certificates, or maybe you have a full CA tree built up. But in CI, you are using a proper certificate that is signed by your company's CA. And then you can just ship this out to your customers, which may have some sovereign or some air-gapped environments where they then have their shim that multiplexes with, for example, Crow, this API to whatever their implementation of a certificate is. And that's the basic idea of what we want to solve with this single API, multiple provider idea. And with that, I will hand over to Robert.
Thank you. One. Okay, so we've just seen where we can find polymorphism when building platforms, and the rest of this session will touch on how you can build your own using KCP. So what is it? On the project's homepage, there are a bunch of small definitions. You can see them on the slide there. For example, one says that KCP is a horizontally scalable control plane for Kubernetes-style APIs. That's a long one. Or that it offers APIs as a service, or that it supports multi-tenancy and fully isolated workspaces. But what I think is the most descriptive definition of those is that KCP really is a framework for building platforms. And to follow up on that idea, let's consider that this rectangle here represents such a platform where we can share services between different users and teams. And when you share a service, there are at least two parties involved. One is the one that gives out the service, provider, and one that makes use of it, the consumer. So we have providers and consumers, two of the many personas we can identify on a platform. And KCP helps us model these kind of relationships in which they communicate together through interfaces, through APIs. And the language of that communication is KRM, the Kubernetes resource model, the thing that powers Kubernetes, but by association also KCP. Great, so we have personas, services, KRM. How do we actually run something on this system? Well, a platform doesn't really have an opinion about how the services it hosts go about their business. It doesn't care about how they are running. You can even think of running something just as one of the many services a platform provides. So KCP abstracts that away, and that's why it doesn't really deal with containers or pods or workloads in general. So when building a platform with KCP, try to think of it in terms of personas and APIs that interact in this space. And then you realize that containers are just an implementation detail. And lastly, KCP is not the replacement for Kubernetes. It's a normal application that you can deploy on your cluster, and we offer a Helm chart, an operator. You can try it out yourself. And when you do eventually try it out, how do you actually work with this thing? When talking to a KCP instance, you do so through something called a workspace. It's a little self-sufficient slice of the Kube API server. It has even its own dedicated URL address. You can see it down there on the slide. There is a manifest of this workspace. And you talk to it with any Kubernetes compatible client because it's KRM compatible. There can be more of those workspaces and they are completely isolated. So all your CRDs, namespaces, in fact, all resources are contained within their specific workspace. They can be laid out flat like this or structured in a hierarchy, and you can walk that structure and enter different workspaces similar to how you would walk a file system, for example. We also offer a kubectl crew plugin that helps you sort of navigate in these three of workspaces, but this is just for convenience. Additionally, KCP can be split into shards, giving you horizontal scaling. So this is how you would, for example, implement your regions in your global installation. Great, so what useful work can we actually do if all those workspaces are isolated and we don't have workloads? Well, we've mentioned personas and sharing services, and in the following example, we are going to do just that. So let's have two workspaces, provider and consumer. Those are arbitrary names, it's just for us to know who is who, but you can choose whatever you like. And in the provider workspace, we create something called an API export. It's a built-in type in KCP that allows you to export resources into other workspaces. And the resource we are exporting here is simply called my service, but you can imagine anything CRD-based in place of that, basically. Then in the consumer workspace, we create an API binding. This is another built-in type in KCP that binds to the export our service provider has created for us. And by doing that, we have that resource available locally in our workspace. So we can create, update, delete, watch objects of this my service resource. And while we are doing that, what does the provider of the service do? Like, how can the provider react to those changes? How does the provider reconcile the objects that the consumer is creating? Well, for that, there is this thing called a virtual workspace that you, as the service provider, own. It is linked to its parent API export. There is a reference between them. And it gives you a zoomed out view of all your consumers who are binding to your export. And similar to a regular workspace, the virtual workspace also is a little slice of the Kube API server, so it has its own dedicated URL that you can stick into your kube config and pass that kube config to an operator that lives in an external runtime cluster. And just like that, we have actually built a fully functional single provider service on the platform. We can, of course, create another consumer of that by creating a new workspace and binding to the export. And by doing that, both of those consumers will now show up in the virtual workspace so that the operator can reconcile them. And that's it, really, for the basics. There is more to exports and bindings that we don't discuss in this session, but the key takeaway really is that this is how you can easily share Kubernetes APIs. And if you put them into separate workspaces, you get isolation, but also you get a workflow that can be called a true provider-consumer experience, right? And then as a service provider, using the virtual workspace mechanism, you can watch your consumers who are binding to your export, but you get access only to the resources that are declared in your API export. You cannot see or touch anything else in the consumer's workspaces. And this is how we do separation of concerns. And lastly, the operators you use today with vanilla Kubernetes work just out of the box with KCP. You don't need to change a thing. Although there is one caveat, you will need to deploy a small sync agent in your provider cluster, but other than that, you can just use whatever you are using already. Additionally, if you need more control, you can use the multi-cluster runtime library to build your own multi-cluster aware operator, but this is for more advanced use cases. In general, bottom line is that whatever you are using today, you're good. You can use it with KCP. And with that, we move on to our first topic of polymorphism, service with a single provider and multiple implementations. So as an example, we can take the concept of PVCs and storage classes in standard Kubernetes. And if we follow the diagram on the slide, we see a user referring to a storage class from their PVC, and in turn that storage class refers to some CSI driver, which is the actual backend specific implementation for that kind of storage. What's important here is that the only interface that you as the end user of this whole thing actually care about is only the PVC. And all this backend specific stuff is hidden away thanks to the indirection that the storage class as a concept represents. We can think of this in terms of generic interface in multiple implementations, right? Like if you imagine the storage class being able to reference different CSI drivers, then once you create a PVC, you will end up with a different storage type based on what configuration of CSI driver and the volume parameters you have provided. And to show you what I mean by that, all of this, we can keep this storage example for around a bit longer and say that if this part runs on the provider cluster and is owned by the service provider, then this part with storage classes needs to be shared between the provider cluster and the platform and be discoverable by the consumers of the service so that they can reference that service flavor from their deployments. And remember that with API exports and bindings, all you can normally do is export APIs and not the individual objects of a resource. And that's what we actually need. We need those individual objects. We need those service flavors to be distributed to our consumers of the service so that they can actually pick and choose what they want. So as of KCP 0.29, if I remember correctly, there is a special replicating virtual workspace that you can export and bind to. And then your consumers of the service can have those individual objects projected into their workspace in a read-only mode. So as a bit of an example, you could, for example, have certificate types, instance flavors of your VM as a service, or storage topology classes of your storage offering. This is the kind of the idea that we wanted to deliver, and now, thanks to that, you can bundle in metadata about a service along with your APIs that you are exporting. There is the link to the documentation, how to set this up. Please try it, complain, give feedback. This is, well, much appreciated, right? Cool, so moving on to the second type of polymorphism, and the last part before we see the demo, service with multiple providers. Nelo has already shown a couple of use cases of that at the beginning of the session, so now we'll take a look at how one might model this kind of setup on the platform. And also remember that this is the actual three-vendor problem, right? Not something solvable by KCP alone, but we do give you at least some primitives to begin with so that you are at a better starting position when building your platform. So we'll start with an exercise. Let's build a service for TLS certificates that we have already seen with multiple completely distinct backends. They might be as well provided by different companies. We don't care. And the naive approach for this would be to build this service with the same model we used for single provider and then just add more providers on top of this and see what happens. So we have done that. The provider brings in their own in-house built APIs certificates.internal.corp. They have created an API export for this, and as it stands, it works. Consumers can bind to it, and they can actually use the service like this. And it keeps on working until the moment we add the second provider, at which point it just doesn't fit in. And there are a couple of issues with this. First of all, we have now two APIs for this certificate service, certificates.cooltls.com. Secondly, we had to add a second API export to accommodate this API. And now, as a consumer, I have a question to which API export do I bind to? What is the API that my application ends up consuming? And then if I ever change my mind and need to switch providers, do I need to now rewrite my application because the API changed and it uses a different schema, so I have to accommodate for this. So as the old saying goes, not great, only terrible. The platform is pushing the problem of distributing APIs onto its users, and this is absolutely not what we wanted to achieve. And that is the main thing. It is our responsibility as platform owners to deliver a common interface for this multi-provider service. We can call it a generic API because it sort of sits in the middle between the providers and consumers. And naturally, anyone who then wishes to talk through this interface must also implement it. So let's say we have done that. We have talked to all the individual parties. They are now implementing this new interface, certificates.platform.corp. And as I said, this is delivered by the platform owner. And now there is a single API export for it. Just what do we do with the providers now? We could kind of shove them together into the same virtual workspace, meaning that we would give them the same Kube API server URL, but then they would see each other's work and reconcile the same object. So this still won't function properly, but we are actually on the right track. And as it turns out, the solution to this is that we can actually partition the virtual workspace by labels and constrain each provider to have access only to objects where this label is matching. So in a principle, if I, as a consumer, create a certificate object, it will be picked up by a concrete provider only once it is labeled appropriately. We have a proof of concept. You can see the link there on the slide. There are still a couple of technical challenges that need to be dealt with, but the general idea and the design is good, and we want to pursue it further. And by the way, we will anyway see it during the demo, so or something like that. And now to get all of this together, as I mentioned, we have a single API and single export provided by the platform. So and consumers then bind to this directly, and they no longer have this question of which export do they need to bind to. Then once bound, the consumer can start creating objects. Those need to be labeled, as I said, before a provider can pick them up for reconciliation. Exactly how this labeling is then carried out is an opinion of the platform. It can, maybe the consumers themselves are allowed to label the objects individually. Maybe the platform has some sort of automation that assigns this label according to some criteria. The point is that it is only you as the platform owner have the knowledge of what are your use cases, what are the needs of your platform, and it is in your responsibility to deliver this piece of functionality. This is business logic of the platform, and like the platform owner is the one who should be delivering that. Then once labeled, the object is visible to exactly one of the providers through the virtual workspace. And then one of those providers picks it up and starts reconciling. A thing to note here is that we are actually in the service provider cluster. We have traveled, the request has traveled all the way from consumer workspace through the virtual workspace, got filtered, and now we are in the service provider cluster outside of KCP, outside of platform. And naturally, KCP doesn't care what APIs you actually use to serve this, to run the service internally in your cluster. However, if the end product of your service, the interface on the object is different from what the platform expects, there needs to be some sort of conversion happening from this provider-specific to platform-specific type. Again, only you as the service owner have the knowledge on how to do this conversion properly. And it's business logic of the service to do that. So KCP has no say on how you should be doing that. And with that, we can actually move on to the demo.
Mm-hmm. Okay. Let's just jump over directly. So in this demo, I'm hoping that this works because we had a few changes. What we are doing right now is that we have 3 kind clusters set up. So if you see 3 kind clusters: broker external CA, broker internal CA, and broker platform. In the platform kind cluster is what KCP is running in all of the workspaces and so on and so forth. And then the separate kind clusters for external CA and internal CA are running the CA with Cert Manager, of course, that actually implements the resource. So what's going to happen now is that we are going to create a certificate. So this down here, example.platformmesh.io/v1 alpha v1. And this will be shown in the consumer virtual workspace, and in between there sits an operator called resource broker. This resource broker takes the resource request, so to speak, from the consumer, from the virtual workspace, and then matches this to one of the providers, depending on business logic. Business logic itself doesn't really matter, but the idea is that we request an internal corp certificate, so it's going to the internal CA. Let's just apply this. So there we can see the consumer cert was applied with the app internal.corp. It was synchronized back to the internal CA. There's created the secret with app internal.com, and that is then synchronized back into our consumer workspace. So if we now see here, there we can see the new secret, age 13 seconds. And now we can unpack it with, sorry for that, it's a bit small, but you can see in the subject that it's appinternal.com. So far, so good. Now we want to change this. We say, okay, now our application needs a different certificate. So it needs one from outside. So let's edit this. In reality, of course, this would happen through like an operator or something, but now we are just changing the FQDN to corp.com. That means this will then be shown in the consumer workspace. The resource broker operator notices that and then creates a new resource request with the external CA operator, the provider. And then waits until this is all done, so until the new consumer secret is done and ready, and only then fails the consumer over to the new resource and then deletes the internal CA. Let's see if this works. So you can see it saw this. Oh, com1, whoops. Okay, now it's actually matching. It's moving over here, it's signing the new secret and syncing all of this back to the consumer workspace. And only then it triggered the deletion here. The secrets are retained because that's just how Cert Manager is configured by default, that it retains the secrets. But yeah, that's already possible today to serve the same API with different providers using the resource broker. Yeah, and with that, we are done. So thank you all for your attention. And if you have feedback, please post it here. And we are, of course, very thankful to the companies that are supporting our work. Thank you. Okay, and then we are right on point. Do we have any question? Or yes.
High-level mechanics of what you're trying to do, which was useful. But I'm curious, like your example is about certificates, but most services there's a networking element, and you didn't touch on that.
Exactly, we don't do networking, we are just managing metadata. So the idea of KCP is that KCP is a basically metadata management system. You are just making an API export is a contract, and a API binding is the acceptance of a consumer for this contract. And then, let's say, for example, you're ordering a Postgres database. Your database team exports the API for this, you are importing it, you're instantiating a database, and then you get back a resource, or your resource is updated with a URL. And that is then how you access your database. Yeah.
But I'm just, in practice, a database was actually going to be my follow-up question. You wouldn't access that over the public internet unless you had to in a corporate setting.
Yeah.
And you would have network security policies and all the rest of the bells and whistles. So does the KCP project help in that in any way, or is it just completely separate?
That's a separate problem. That's kind of what then platform mesh goes into, sort of, as in that so KCP is just the platform that you can, the building block that you can use to build a platform. And what we are trying to do with platform mesh is to make a opinionated complete set that you can then deploy, and that as, for example, also terminal servers and stuff like this. That's what we are working on there. Something like network tunneling would be in the scope of platform mesh, but not of KCP itself, because in KCP we are just doing metadata and nothing else. Any other questions? Okay, perfect. If you have questions later, we have get involved pages with all of the links to our user channels on the Kubernetes Slack and on Zulip, and we have mailing lists. So just send us whatever you questions wherever you want. We are always happy to get people asking questions. Okay, thank you.